All right. So my name is Tanner Whitmire. I pursue agricultural autonomous vehicle development for NOVATEL. For those of you that may not know who NOVATEL is, over the past 25 years, NOVATEL has been providing assured positioning for numerous of our trusted partners. Some we have listed here on the screen. NOVATEL is actually a part of Hexagon Position Intelligence, and Hexagon Position Intelligence just recently acquired Autonomous Stuff, who you may be familiar with in the automotive industry. Autonomous Stuff is currently serving over 1,000 customers and has built more than 450 research and development platforms for the aid of robotics and autonomy. It's our mission to develop, produce, deploy the most trusted positioning, assured positioning, anywhere, while providing exceptional support to our customers. So one of the key influencers that we believe that's going to be required in accelerating AV development is going to be in positioning sensing. And arguably, positioning sensing influences just about every component on the machine. So today, the incorporating functional safety solution, it's really going to be up to us as I've identified the safety standards that are out there are really all more about the automotive industry. However, the technologies are somewhat similar in the automotive industry as we have in agricultural, but the application that we'll use them for is quite different from on-road to off-road. Up until the vehicle started running autonomously, positioning was really more about historic information based on what you're going to do with that information, making management decisions. As the vehicles run autonomously, remove that operator of the cab, absolute position is going to be crucial in having a functional, safe machine. Not only will the vehicle need to know where itself is, it's also going to need to know relative what's around it, the distance it is from a different obstacle. It needs to be able to detect these obstacles from a situational awareness, operational safety standpoint. Not only does it need to detect to define whether it needs to deviate from its trajectory, it will need to be able to identify and classify the situational awareness of the vehicle. Is there a person standing next to me and I cannot spray? Am I too close to the tree line? These are all different challenges that are going to come into play in incorporating a functional, safe machine. So our approach in incorporating functional safe is really to go off the information that we've learned in other industries for implying a safety solution. One of the things that we do know is there are additional challenges in a functional safe design when it's based on GNSS. The system itself is going to be a complex system of systems that must flawlessly work together. So one of the things that we've learned is in the aviation industry is we've studied the integrity of the WAS system, so we know how the system can fail. We currently have ongoing research, 3 years and counting, with universities in the automotive industry, where we are studying positioning automation for on-road autonomy. So as we've uncovered different information on how these things can fail, it's understanding how these systems work together and time stamping these different sensor technologies, fusing the different sensors and compute platforms together to provide a functional, safe architectural system. And it's those pieces that are going to be required into developing a full functional, safe solution and accelerating the development of an autonomous vehicle. And that's the pitch, if anybody has any questions.
You were very synthetic. Alors, on a encore plus de temps pour des questions. Maybe some use cases in the ag industries or some clients you're working with?
Yeah, so outside of the component itself, I mean, we're going to need a functional, safe component. You're going to need the software in addition to the component as well as the full architecture system. So those are core pieces, but some of the other things that's going to come into play is security, where we've seen already in other industries spamming and spoofing of GNSS networks. One example is hauling trucks that now have to have GPS systems on there to record the timestamps that they're driving so they're not overdriving and so forth. You can go buy a spoofing device from a truck stop and it knocks out the entire GPS system. So it's these types of interferences that are going to come into play that we see in the agricultural industry that is going to be a key piece into the actual functional design system to make sure the vehicle is operating safely.
And what about standards? Are you involved in developing standards on those topics?
So today we are incorporating safety. All the devices that we are producing from a GNSS standpoint, we are going after ASIL D. So one of the differences that we see in the automotive industry versus the agricultural industry is the level of accuracy. So in ag, on service is RTK level accuracy, couple of centimeters, where in the automotive industry, set of safety standards could be something like 1 meter. Well, 1 meter accuracy in agricultural does not get the job done when you are on surface. So what's the system look like to have a functional, safe solution while maintaining accurate service capabilities?
There's a question there.
Yeah, hi, it's Rowan Rainbow from Australia again, just over here, if you're trying to see. Just behind the camera.
Oh, gotcha.
Yeah, one of the issues that's been discussed over quite a number of years in Australia, and particularly because we're so dependent now on the use of real-time kinematic GNSS systems, is the potential risk of solar cycles in terms of interference on our systems. And you got any comment about strategies that you've been looking at as a company, either through correction systems or base station systems, to actually try and sort of, I suppose, as an industry, manage risks of solar cycle interference? And perhaps for those who don't understand what I mean, you might want to explain it.
Yeah. Actually, I was trying to find you. Can you rephrase the question one more time? Sorry about that.
The question is around the issue of solar cycle interference from the sun and the issues that it has around ionosphere interference and risks particularly to very accurate 2 centimetre systems, and the types of strategies. It's an issue that's been talked about from time to time in Australia because of our dependence, but you've got any comment on some of the long-term thinking about how we can better manage these, particularly when we look at very, very accurate systems?
So I don't have any specifics that I can comment as far as the interference that goes there, but one of the takes that we are incorporating from a functional safe solution is having control from the start to finish. So for one, we'll have control over the receiver itself. 2, we're providing correctional services, TerraStar subscriptions, so we'll be able to own that network as well as control from start to finish. The only thing that we wouldn't own in this situation would be the satellites themselves. But by being able to control the signal that is going down to the customer and the level of interference, gives us the capability of providing more accurate and sustainable solution.